Hello, Mr. Muis. My name is Daniel Kevin Siboro, and today I'll be presenting my Embedded System 1 project, which is the water level detection for refilling drinking water. So this project was made to monitor the water level of my drinking water container and to alert us using a buzzer if the water level is at the desired level, and to log the data in an Excel sheet for analysis, and this will be done in a Google Sheet Excel sheet. This is the system architecture for my system. On the left we can see the schematic. We can also see the hardware interconnection of the system. So here I will be using the ASP32, the ultrasonic sensor AC SR04, and a 3.3 volt active buzzer. And I will also be using a power bank as a VCC or a voltage source for the ESP32. On the right we can see the physical system architecture. Here we can see that I will be attaching the ultrasonic sensor on the lid of my container so that it will check for the distance from the sensor to the water. And here I'm also extending the jumper wire for the ultrasonic sensor so it can comfortably reach the lid. Next is the Arduino code. So for the Arduino code, I will be using 4 libraries here. These libraries will help me with making my web server and also for data logging. So here we can see that I'm defining the pins for my components and also initializing some variables for my code. So first we can see that there is a constant char main page. This is the part for my web server. This is made in HTML, and here I'm just making a small sort of shape to contain my sensor value just so it looks nicer, and it is called card, and I will be using it for displaying the sensor value, as we can see here, where I use the span ID water level. Okay, so next here I am using some JavaScript to make functions, and in this web server I will be updating my sensor value asynchronously or in accordance to the set interval function that I've set for 2 seconds. And here I am using Ajax to request data from my other functions that I will get to later. So here we can see that it will obtain the value and then set it for the water level ID. And the next function is the handle root function. This function is for handling the display page or the main page of the web server. And then the next one is the handle level. This is the function that handles the turning on and off or managing the ultrasonic sensor and calculating the water level. And then in the next part we can see the part where I will be sending or posting the value I obtained from the ultrasonic sensor to the URL or to the Google Sheet. And next we can see the part for the buzzer. So I've set it so that when the distance or the water level is above 40 centimeters, the buzzer will turn on for 5 seconds and then turn off. And then in the void setup, I have of course initialized the serial communication for serial monitor. That is for checking for the local IP and checking if the system is working properly, and also setting the pin modes for the components, and then starting the Wi-Fi connection using the SSID and password, and then also the server functions for the web server. And then in the loop there is only one function to handle the server functions. So this is how I take my measurements for my project or for my system. So here I have attached the ultrasonic sensor to the lid. So now it is facing down towards the bottom of the container, and it will be measuring the distance between the water and the sensor. So here I will be plugging in the ESP32 into my power bank, and then now I will turn on the ESP32. We can see that it's on, and now I will check the web server for some initial values. Here we can see the values right now are not exactly correct, so we're trying to find the consistent value. So here I get the consistent value of 32.83 in the web server, and we can also then see in the Google Sheets Excel file that the data is being recorded as well. Okay, so a few minutes has passed, and now the value is a bit higher for the sensor, and we can see that in real time the data is also being sent to the Google Sheets file. And so let's also fast forward a bit. Now the value is at 35 centimeters, almost 36 centimeters. Okay, now it's at about 37 centimeters. Okay, now that it's at 40 centimeters or above 40, we can hear the buzzer turning on, and it's turning on for 5 seconds. And this sound is actually loud enough for us to hear it from our living room. Next, we have the results I have obtained from my measurements. I've done 2 measurements on 2 separate days. First was on the 30th of June, and the second one was on the 1st of July. And we can see here for the first one, this one was done on the 30th of June, which is the left graph. We can see the increase of the water level from about 34 centimeters to about 40 centimeters. We can also see some, we could say, outliers, and this happens most likely due to the ripples of the water when we are refilling the water, or maybe splashes of water, or maybe also some errors from the sensor. And on the right, we can see the data I have obtained from the 1st of July. It is very noticeable that there is less data samples here. This is because the water level started out at a higher water level, and we can also see that the graph ends at about 40 centimeters. So these are the end results we can see from the container. We can see that the water level is almost full compared to the container, and we can see in both measurements that the water level is almost the same, and the water is at a level that is enough for us.